Today we're covering absolute value. So when looking at this equation, what are the possible solutions that would make it a true statement? Let's go with Carter.
Absolute value of negative 5 equals 5.
Okay, so I could substitute in, how about if we go with 5, positive 5? Okay, does that equal, since the absolute value of positive 5 equals 5, that's a true statement. And he also said, let's substitute let's go slower. He also said that we could do a what? A negative 5. So the absolute value of 5, negative 5 equals 5 as well. That makes a true statement. So I have two solutions. We can write that in a couple different ways. We can put it into a solution set. Negative 5 and 5. The braces imply a solution set. Okay. What about for the next problem? What are the solutions to the next problem? What do you think?
There is no solution because absolute value can't be negative.
There is no solution because absolute value can't be negative. Julio?
Oh, you have to put the negative outside the line?
No, in this situation, we can only substitute for what's given. We can't add other things to it. Do you understand?
Yes.
We can't add. So what in this situation will work? If I substitute a negative number, does this make a true statement? Is this a true statement?
No.
No. If I substitute a positive number, does this make a true statement?
No.
Okay, if I substitute a 0, does this make a true statement?
No.
So she's right. There is no solution. And I'm putting this on film because we're recording right now, but I'm going to tell you, I'm going to give you a tricky problem. And that problem is going to look really scary, and it's going to be something like this, like, 5 over, x squared plus 2 in absolute, equals 15, negative 15. Now, do you know how to solve that?
No. You can't.
Right. But it's going to look scary, and you're going to think, well, maybe I can solve that. Maybe when you get to chapter 10, you can. But anytime it's equal to negative 15, a negative quantity, what are you going to say? No solution. And I will trick you, as other teachers will do that too. We'll make a really complicated absolute value problem, maybe even a calculus problem, but set it equal to negative. And what are you going to say, Mark?
No.
Good. So what would my solutions be for number 10? Solutions for number 10. How about Ashley?
It'd be,
Sorry, number 1.
it's negative 10 or 10.
Negative 10 or 10. Go, Matthew.
For number 2,
Uh-huh.
it could be negative 4 or 4.
Good. And then number 3. Let's go, Bryce.
0.
0. That's it. All right. Pause the recording and do 4, 5, and 6.
Negative 5 or 5.
Okay, let's try that. The absolute value of negative 5, does that equal negative 5? What's the absolute value of negative 5? So is 5 equal to negative 5? No. So is that a solution? No. Okay, and what was the other one you gave? Okay, so does the absolute value of 5 equal, what's the absolute value of 5? Is 5 equal to negative 5? So what is my solution here? No solution, because it's a negative. Do you see how you fell for it?
Yeah.
It's very automated. So, guys, just keep your eye out. Maybe highlight that, right? It's a no solution. Now, the next one's a little bit sneaky. In math, we get lazy with ones. But if you see a negative, that's like having a negative 1 right here. Do you see that? It's like having a negative 1 right there. And that means negative 1 times the absolute value. So in this case, what did you get, Alan?
I got negative 14 or
So let's try negative 14. Okay? So it's negative 1 times, what's the absolute value of negative 14? 14 equals negative 14. Yep, negative 14 equals negative 14. So that works. Let's try another one. Let's go you said negative 1 times the absolute value of 14 equals negative 14. So negative 1, what's the absolute value of 14? Go.
14.
14. Does this work? So he is correct. Is there anything else? Go. You can do it like that, or you may do this in your answer column. Plus or minus 14. Okay? Either way. Means the same thing. Okay, last problem. Go, Veronica.
3 over 4 or negative?
Yep. 3/4 or negative 3/4. Okay? All right. Now we have equations. For us to solve, we know that this entire absolute value, I know that this whole thing has to equal what? What?
X plus 3.
No, what does the whole thing have to equal? Go.
15.
15 or
Or,
what else could go in there that would make it a true statement? No, what does this whole thing have to equal? 15 or negative 15. So right away what we're going to do is to lose the absolute value, you're going to create two equations. X minus 3 equals, let's notice, x minus 3 stays the same, except I didn't write it properly. And then the other one is also x minus 3 equals. So what changes in the equation? Ashley? The sign of the result. So one's going to be positive and negative. When you break it into the positive and negative, then you lose the absolute value. And now we are going to add 3 to both sides in the first equation. Okay. And then I have x equals 18. And what am I doing to the next one? Harry? To get x alone, what do? I also add 3, and we get x equals negative 12. Now you should be able to check these. Put the solutions in the absolute value. Is negative 12, negative 13, negative 3 makes what?
Negative 15.
Is this a true statement? Yep, because the absolute value of negative 15 is 15 equals 15. You should be able to check that. Try the 18 too. Is that a true statement? It works. Okay, questions? Okay, next.
instead of doing that bracket thing, because I don't know if
Braces?
the braces, can I just
Thank you, sweetie.
put parentheses? Or do I have to-
Parentheses. No, you can't. Parentheses mean an ordered pair on the number on a coordinate plane. If you do this, it means something completely different. So do not. But what you can do, like I'm not very good at making them either. I go like that.
Can I do brackets, or that's also a different thing?
It's braces. Braces imply a solution set. That's the only thing you can do. Brackets is just a glamorized parenthesis. All right, questions there. Sophia. Okay, any questions? Go, David.
Off topic, but if you put like two numbers in between brackets, does it?
It's just a glorified parenthesis. Yes, it kind of does, but that's later on. implies a list of multiple numbers, a starting point and an ending point. I'll kind of bring that up again in chapter 9. All right, so before I can even branch, I have to isolate the absolute value, treat it like a variable. Max, what would I do to get the absolute value alone?
I would subtract 7.
Subtract 7, good. Subtract 7, and now I'm ready to do my branching. What would be my next step?
Subtracting, adding 3.
Not yet.
Oh.
We don't do any math before we...
You would...
Okay, Bryce?
Would you simplify it out of
What?
Would you like take it out of
Yeah, how do I lose the absolute value?
you change up the negatives to positives?
No, I don't change all the negatives to positives.
You write them into different equations.
2 equations, and my result gets set to 1 positive and 1 negative. Do not touch that middle sign. Do you understand? So we're setting it, we're branching it out to 2 equations. One is set to the positive, and the other is set to equals what, Bryce?
Negative.
Negative 25, right. And now we can keep solving it. Finish it up, guys. Finish it up. All right, so what are we doing first? Let's go with Elizabeth.
So you add 3 to both sides.
Good. I'm adding 3 to both sides. And then we have?
Then you have 2x equals 28, and then you divide by 2 both sides.
And
you have x equals 14.
now check it. 2 times 14. You can check it here or here because these two are equivalent. 2 times 14 is 28, minus 3 is 25. Does it work? Yes. I'm doing the same thing over here, only this time I'm left with a negative and a positive we have to subtract, and x equals negative 11. So that would make negative 22 minus 3 is negative 25, and that works. Yes.
On our homework, do we have to do both sides or just one?
Oh, yeah. You're going to have to. Well, your equations aren't going to be that complicated. They're not doing big ones like this. In chapter 9, you will. Okay, go.
Can you just check in your head or just
Yeah, you can just check in your head. Okay, what would we do here? When 3 is next to absolute value, what operation is that, Rami?
we divide
We're going to divide by?
3 on both sides.
Good. Now what, Rami?
You want to make it so that it's like equal to positive. I don't know how to say it, but like equal to positive and negative.
Positive and negative what?
6.
6. So x minus 4 equals?
6.
And
X minus 4 equals negative 6.
perfect. Once you're in 2 equations, and then we're adding 4, using our inverse operations, always properties of equality. And do those work?
Yes, they do.
Okay, so we're checking them. Okay, questions? Okay. Okay, so now I want to know, determine whether each statement is always true, sometimes, or never. Always, sometimes, or never true. So in this situation, I want you to try with a negative, a positive, and 0. I just go with negative 1. Does negative 1 work?
Yes.
No. Okay. Does 1 work? Okay. Does 0 work? So what would we say? Always, sometimes, or never? Sometimes. Good. Next one. Try a negative. Try it, guys. Try it on your paper. Try it with a negative. Try it with a positive. Try it with 0. Okay, does it work with a negative? What does this become? That becomes, the absolute value of negative 1 is 1 times the negative is negative 1. Is that less than or equal to negative 1? Okay, that works. What about here? Does it work here with positive 1? Yeah. Does it work here? So what do we say? Always. Good. Next one, what do you think? Does anybody have the rule that it won't work? Eitan.
Yes, I know the rule. It's negative 1.
Negative 1.
Wait, no, it's 1.
It's positive 1 and positive 1. You're correct.
Thank you.
So that breaks it. Is there ever a time when it's correct?
Yes, negative 1.
Negative
Because-
1 and
because-
negative 1?
Yes.
That's going to be positive 1 is greater than 1. That's not going to work. Okay, so let's see. You said positive 1? That works with positive 1. Negative 1 really becomes up. Let's try negative 1. So I'm going to say 1 is greater than.
Which is not.
That's not a true. So it's sometimes. What about 0? 0, it's not going to work. Okay, next one.
Sometimes.
Sometimes. What works? Does 0 work?
No.
Does a negative number work?
No.
Does a positive work?
No.
So never. You get the idea?
Oh, yeah.
Okay, try the next two. Pause the recording. Up with for number 5. For number 5, Carter.
Sometimes.
Sometimes. What works?
Positive 1.
So positive 1. That's correct. Because it was a positive 1, then multiplied becomes a negative 1. Okay, does negative 1 work?
Yes.
Negative 1. And then I'm going to do this. Negative 1. So that's still going to be a 1. And that's going to, yeah, that'll work. What about 0?
No.
Okay, so sometimes works. Okay, last one. Last one. Eitan?
Always.
Always? Okay, I want to do one problem from the homework because the homework challenger problems are much easier than I think in the PowerPoint. So let's just do one here. So like number 44, negative 3, absolute value, m, plus 5, absolute value, m, minus 3 equals 1. So what's the easiest part to get rid of here?
Dividing by negative 3.
No, because there's 2 sets of dividing. So
Minus 5.
that looks like it's going to be really complicated. Okay, Carter, what do you think?
Get rid of the absolute values.
Nope, not yet. We're peeling it like a onion. Get the outer layer first. Shivam.
Adding the 3 to both sides.
Add 3. Add 3. Now, what we have is our rule of combining like terms. And then equals, hold on. No, we're not dismissed. Do not pack up. So be 1 second. So now what do? Think of it like it's a variable. They're like terms. What do, David?
Add them together.
And what does it become?
It becomes
2,
2.
absolute value of m equals 4. Now what? Now what? Go. Divide by 2. Absolute value of m equals 2. And so what are my solutions? Plus or minus 2. Okay. Good day. Thank you. Our test this week is on Thursday. Huh? It's on the board. Oh, the homework is section 3A, page 146, 1 through 53.